So once we have completed the part A of the problem, let's have a look at it once again. They're telling us to find out the distance traveled by the particle after time nt. And once again, you can see from this table, in the first interval of duration t, displacement was half at square. The second interval of same duration, it was 2 at square, this 9 by 2 at square, 8 at square, and so on. And when they look for the distance traveled in time nt, we have to find out the total sum of this progression whose terms are half at square, 2 at square, 9 by 2 at square, and so on. So let's keep that in mind and write it here, that you have got a series whose terms are half at square, 2 at square, 9 by 2 at square, 8 at square, and so on. And suppose the sum of this series up to n terms, that I denoted by the symbol Sn dash. For distinction, I already used Sn here. And suppose for this series, the nth term that I take to be Tn dash. And remember, this Sn dash is representing the displacement of the particle in time nt. So I'm writing once again that Sn dash is equal to half at square plus 2 at square. Since the particle is traveling in the same straight line, that is x-axis, the displacement, total displacement, is nothing but simple arithmetic sum of the displacements in different intervals. That's why I'm adding it up arithmetically. 9 by 2 at square plus 8 at square. And this way, suppose the nth term of the series is taken to be Tn dash. Once again, I write this thing Sn dash, same technique as done in part A of the problem, writing the same summation, but this time just shifting them one place to the right. So the first place is kept vacant. I shift half at square below 2 at square, then 2 at square is coming below 9 by 2 at square, 9 by 2 at square is coming below 8 at square, and so on. And this way, the term before the last, that is n minus 1th term, that is coming below Tn dash, and Tn dash is coming one place further to the right. Once you have written so far, let's once again subtract these two equations, and these are all get subtracted. Now Sn dash minus Sn dash, that is giving me 0 on left hand side, right hand side. This is half at square plus 2 minus half, 3 by 2 at square, 9 by 2 minus 2, this is coming out to be 5 by 2 at square, 8 minus 9 by 2, that is 7 by 2 at square. This way, if you come up to this, Tn dash minus Tn minus 1 dash up to this is giving me up to n terms, right, for the series already getting formed. Let me keep inside a square bracket, and remember I have got a minus Tn dash waiting for me. So once we are here, let me transpose and write down what we get for Tn dash. So we are getting from here that Tn dash, the nth term of the series, is coming out to be, well, within this series I can take half at square as common, and I'm getting it is 1 plus 3 plus 5 plus 7 plus up to n terms. A typical arithmetic progression, and we know how to find out the sum. To remind you quickly, we have got this formula for an AP, that the sum of n terms is given by number of terms by 2 into, inside bracket, twice A plus n minus 1 into D, where n is the number of terms, a is the first term, and d is the common difference. So in my case, if we look at the series inside the bracket, the first term is 1, common difference d is equal to 2, and the number of terms is n. So applying this formula, we could write down that Tn dash is coming out to be half into at square, and then it is n by 2 into 2 into 1, that is the first term, plus n minus 1 into common difference, which is 2 in this case. Let us see what we get from here. It is 2 plus 2n minus 2, that is giving me just 2n into n by 2, giving me n square only. So I'm getting this is coming out to be half into n square into at square. If you are a little quick and careful, you can even see that by inspection, that first term is 1, first two terms 1 plus 3, that is 2 square, first three terms 1 plus 3 plus 5, that is 9, 3 square, and so on. Therefore, the sum of n terms is coming out to be n square here, and I got this is the value of Tn dash. Remember, we are supposed to find out the sum of this series, that is Sn dash, as the displacement in time nt. So once we got Tn dash to be half n square at square, we might write down here the sum of the series Sn dash, that is given by sigma Tn dash, where the value of I is changing from 1 to n. This is giving me sigma I is equal to 1 to n. Just now I got Tn dash to be half into n square at square. From here, I take out half at square, left with sigma n square. Once again, recalling the formula of progression, this is giving me half at square into this quantity, sigma n square, I is equal to 1 to n. You can refer to your notes and see this is coming out to be n into n plus 1 into 2n plus 1 divided by 6. Just check this one. So once we have got this Sn dash to be this quantity, let me write my result somewhere clearly. We have got that at time t is equal to nt, the total displacement of the particle traveling along the x-axis, that is, well, let me call it delta x. This is equal to the sum Sn dash that we just now found to be 1 upon 12 n into n plus 1 into 2n plus 1 into at square. This is the answer of second part of the question.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.